This is the Tekmar 261 training video. Typically when you come to a Tekmar control, you'll see it doing something like what you're seeing right now, where you have it's in the view menu showing the boiler water temperature. You can cycle through the display by pressing the item button. You can get the target boiler water target temperature, the current outdoor temperature, and then back to the boiler water temperature. If you want to get into the adjust menu, you hit all three buttons at the same time, and that'll get you into the programming mode. If we quickly go through the icons on the display, you can see that the Tekmar control is currently showing a boiler demand. The boiler pump system pump is to be on right now. It's in occupied mode. It's just the temperature has dropped and it started looking for a first stage firing. If the temperature drops some more, you'll see it kick into second stage, and then obviously the boiler should have the corresponding second stage firing as well. If you wanted to change the settings on this control, once again, push all three buttons at the same time, and then it switches from what was previously said view, it moves to adjust, and it's flashing room OCC, which tells us that's the room occupied setting. This setting and the corresponding boiler indoor temperature are set at the same set point. If we go back to that room OC setting, I'll let you know that this is the setting that you would just tell your customer if you wanted to give them some ability to adjust the temperature or tweak the temperature. You would say just go to room occupied, set this temperature up or down depending on whether you wanted the room, if you wanted it hotter or if you wanted it colder, set it below the 72 degrees. And this is what it does in the internal control, is it does a parallel shift of the heating curve that you're going to set in the further adjustments down the line here. The next setting is the room unoccupied, which is typically not used in commercial, so we can ignore this one. The next setting is the outdoor design temperature. This is currently set at a very conservative -13 Fahrenheit, which is about -25 Celsius. The reason it's set like that is because you don't know where the sensor is located. If it's on an outside wall, on a warm wall, that wall could be radiating heat onto the outdoor sensor. So even when it's -30 degrees or -35, the outdoor sensor may still only be reading -25 or something around that mark. So you start with a conservative -13. If that tends to be too hot, you can always change that later, or the building operator of the building could change that. The next setting is the terminal unit. This is a little bit confusing on Tekmar controls because their labeling is a little confusing to what the trade calls things. They have this terminal unit set as terminal 4, which Tekmar terminology calls it a fan coil or a finned tube convector. However, they have another setting called baseboard, which is setting number 6. In their manual, they explain it a little bit more in detail, and what we use in our climate is a fin tube convector, so we set ours at terminal unit 4. The next setting is the set point setting. This one is set at 180 degrees. This is only used if you're running a domestic hot water system off the boiler heating system. So typically not used, but if you were, you would need to have a individual set point demand, and then you would set this at roughly 180 or whatever the inlet heat exchanger water temperature was set at. Like I said before, the next setting is boiler indoor temperature, which is set the same as the room occupied temperature. The starting set point is usually 72 degrees. Boiler design. This is the temperature that was the maximum temperature during the heat load calculation when the building was built. Now obviously we're not privy to that design conditions when it's a retrofit application, so you can typically use on a 4-story walk-up with leaking balcony windows, set it at the maximum, which is 190 degrees. The boiler maximum, this is typically set about 20 degrees higher than the boiler temperature in the previous setting, and that's because the extra 20 degrees gives the controller some differential to operate the boiler until the boiler water temperature reaches the 210, and then it shuts off and then doesn't short cycle on the high limit. The next setting is the boiler minimum temperature. This is something that you have to be very careful if you're running a steel boiler or a copper fin boiler. Steel boilers, typically, they can't handle anything below 140. Copper tube boilers, anything below 130 creates a condensation problem, and with obviously condensation on a steel boiler causes rust, and the boiler will rust out and plug up fairly quickly. Copper tube boilers are the same. If they condensate, there's a green buildup that will occur on the copper. That buildup will then plug up the tight fins, and then it will carbon up, and then it will be plugged up. So we maintain a minimum temperature 130 to 140 depending on the type of boiler that you have. The fire delay, this is typically found on more advanced boilers, or used on a more advanced boiler, something that has either an induced draft or a forced draft fan that causes the heat exchanger to need a timed purge. So if you have a purge that's a minute, you'd set this at a minute, or a 2-minute purge, you'd set this at 2 minutes correspondingly. But if it's an atmospheric boiler with no purge, just set it at 0, leave it like that. The differential, always set that at automatic. I've never had an application that needed this to be set at anything other than automatic, because the controller will figure out what the optimum setting is for the differential of the boiler. If there's a problem with the differential, it typically has to do with the location of the Tekmar sensor and the flow rate through the boiler. If the flow rate is really low, you get a very high temperature rise across the boiler, and then typically you have to move the sensor to the return side so that it's only sensing the heat after it's come back from the system. The next setting is warm weather shutdown in the occupied mode. Now this setting, obviously it depends on the tenants of the building. If it's a typical building with uninsulated heating pipes, you can set this setting at 60 degrees. That'll shut the boilers down when the outdoor temperature reaches 60 degrees. But if it's in an older folks home, and the people in the old folks home usually like their heat till it's 70 or 65 or 70 degrees outside, you're going to have to move this number up. Otherwise you're going to get a nuisance call when there's no sun shining and there's no solar heat going into the building. That building will typically be fairly cool, and you'll get a call that they're too cold or the boiler's not working, when it's actually just in warm weather shutdown mode. Warm weather shutdown in the unoccupied mode, that's the same thing, but it's not used typically in commercial. The last setting adjusts whether or not you want to have it in Fahrenheit or Celsius. I typically leave them in Fahrenheit. You can click to the next setting, and the ESC just gets you back into the regular operating mode. Regular operating mode allows you to still see the boiler operating temperature, the target temperature, and the outdoor temperature.